So tonight's event is a partnership between the Labrador Institute, the Labrador Heritage Society, Grenfell campus of the university, and College of the North Atlantic, Labrador West campus right here. And as you know, the theme is the Northern Lights, the science, the mystery, and the photography. And we have 3 presenters lined up for this evening. And we'll take a short break after the first presenter, and then we'll continue on with the final 2 presenters after the break. Okay, so our first presenter is Mr. Stephen Day, and he is coming here. He came all the way from Cornerbrook Grenfell campus to be with us tonight. He's one of 2 operators of the Grenfell Observatory, and he's a laboratory instructor for the physics program at Grenfell campus. Stephen grew up in Cornerbrook, Newfoundland, and graduated from Grenfell with a Bachelor in General Science with a minor in chemistry, physics, and math. He's currently studying tidal heating of planetary interiors on Saturn's moon Enceladus while working on his master's. At the observatory, he operates the telescopes where he uses to view the sun, the planets within our solar system, and deep space objects like galaxies, star clusters, and nebulas. Stephen is also very active in many forms of astronomical photography, including stellar spectra, false color imaging, meteor shower observations, and basic digital telescopic imaging. He has always had a deep passion for space and looks to share his knowledge with the public in a hope of sparking interest beyond Earth's upper atmosphere, or further the public's understanding of space phenomena. So, welcome, Mr. Stephen Day.
Hello everyone. I had a bit of a crazy trip down here today, and I hope my audio is good because I'm not used to a classroom this size, so if anyone can't understand me, please speak up now and I'll raise my tone a little bit more. Good? Everyone's good? Great. I'm used to speaking in a dome, really shags up audio. You'll see what I'm talking about in a second. Alright, oh, that's not good. Alright, so tonight we're going to look at auroras and what actually is behind the phenomena that causes auroras. Right here we just got a basic picture taken from the ISS. If you look right here, you can see a portion of the International Space Station. It's actually looking over the southern hemisphere there, so it's actually not Aurora Borealis in this picture. It's Aurora Australialis. That's what they call it down in the southern hemisphere. We both get it. They don't get to look at it as much because everyone knows about the southern hemisphere. There's not a whole lot of land mass to stand up on, unless you like standing on polar ice floes down in Antarctica. But before we get into auroras, I'm going to tell everyone what we do at school. So I work at Grenfell's Observatory. This is the observatory here, despite the fact that most people at the school doesn't know what it is. It's a large 10-ton dome that sits on top of the school, literally sits, it's not fastened. The whole unit completely rotates, and this top flap here pulls back, as you can see in this image, so we can get a view of the night sky. There's no such thing as turning hand cranks or anything when you're in there. It's all mouse, click, push button, and it doesn't work for you. This is our little telescope here. Full computer control. This is actually 3 telescopes in one. So this little tiny one here is called a Coronado. That's a telescope specifically designed to look at the sun and only the sun. A little bit later on I'll show you some pictures we took with it. This telescope actually made the trip to North Carolina the past summer to get some pictures of the total solar eclipse. Next to it is a refractor called the Vixen. This is a spotting telescope. If you went to most people's houses who are astronomers, they'd probably have that as their good telescope. That's about a $15,000 unit. We just use it for looking around because when you look through this one, it's really hard to find an object. So the one I've just mentioned right here, this is our reflector. That's a DFM reflecting telescope. Down in the bottom is a 60-centimeter mirror with a hole in the middle. Everyone wonders why it has a hole in the middle. It's because we collect light through this opening. It bounces off the rear mirror, and up on top is a little tiny mirror about that big. Condenses all your image and puts it back down through the hole in the center of the lower mirror. You can't see it real well here now, but there's actually an eyepiece hooked up right here to the telescope. Almost all the pictures we take are in black and white. Sorry, I'll explain that a little bit later, but it's not like we look through and see a National Geographic magazine or anything. All our imaging is pretty dull until we put in some false coloring to bring it to life. Another thing about our unit is, you'll see right here is a power pack. All our cameras are cooled. So none of our cameras run at operating like room temperature. They all operate at minimum -42. They all have big cooling plates. The reason why is when you're looking at something that's like 20,000 light years away, the slightest vibration distorts an image. Sure, that can be understandable. If anyone ever moose hunts or anything, and you look at a moose that's 400 yards away and you sneeze, it's kind of hard to find that moose again. So vibrations on a camera, that's something on that far is even worse. So this is our observatory. We actually do public tours. If you're ever in Corner Brook and you hear of a tour going on, come on down. We also do a lot of tours for school groups and that, so it's really rare. I got a variety in age. Usually it's like all grade 9s or brownies, beavers, it ranges in anything. So here's some imaging we do, and like I said, black and white. Why? Reason why we do black and white is because when you collect in black and white, you get more detail in your images, well, through the cameras we use. And believe it or not, when you're working in color, it's harder on your eyes to do any adjustment to look at anything in space. So when you're up in our telescope, everything's red, all our lights are red, so it looks like a party's going on, and all our images are in black and white. That way your eyes don't have to adjust to the lighting in the rooms. So, well, this one's not black and white, this one's actually normal color, but this is the solar eclipse in northern Carolina this summer. Our Russians at the school took the camera down and took a few pictures with the Coronado. This is the northern pole on our moon, so this will give you an idea of the magnification of our telescope. This is a full sky shot with the camera I actually brought up here, but I'm not sure if I'm going to use it because it's frigid out and it might freeze up. So this here, we get full sky shots. We actually set these to run all night. This will take a picture every 15 seconds, and what we do is we'll put it on during meteor showers, and we'll get a count on the number of meteors that night. So what we get is we'll just get a few streaks. Of course, this image doesn't have any streaks. Wasn't that lucky. And this one here is actually, this guy in the middle is a star that's up in a dog in the sky called Sirius, or Canis, sorry. This star is called Sirius. If you looked at that any night, it looks like one star. But if you look really close here in this image, you'll see it looks like a little mole on the side. That's actually a second star. It's called a binary star. The big one is called Sirius A, the small one's called Sirius B. It's called the pup. It actually rotates around like that. Every now and then the pup gets really close and it actually sends radio waves to Earth. And we can pick it up on satellites, but it's just clicks. No one really likes clicks unless you're a nerdy astronomer. Or I think there was a movie about it too, but it didn't follow Sirius A or B. So I work at the physics department in Grenfell. If anyone's ever interested in coming up to study, we offer a 4-year program through the School of Science and the Environment. You can study astronomy, particle physics. We actually got 2 leading particle physicists in the world, 2 Russians, Svetlana Barkanova, and I'm just going to call him Alex, because if I try to pronounce his real name, it's a real battle, and no one's ever going to probably pronounce it again. We do electromagnetic theory, thermodynamics, and computational mechanics, or mathematics. If you do study any astronomy, you get the opportunity to use the telescope and the full observatory, and we also offer summer student positions in the summer to help us do some research. Outside of that, because everyone loves the observatory, you know, $2.5 million kind of catches people's eyes. But then we also do a broad range of experiments in our 2 labs. We actually have a new lab that was put in with the extension of the telescope being put on the building in 2013. But enough about Corner Brook. Well, I'll tell you one thing about Corner Brook, we don't get northern lights. Does anyone know why? We're further set. We also got way too many city lights, so we get a lot of light pollution. The sky pretty much glows there all the time, so most of the time we see is you head over to the North Shore and you can catch a few arcs coming down off the northern sky. So, what is Aurora Borealis? Auroras is an electrical phenomenon characterized by the appearance of streamers of reddish and greenish light in the sky. I don't like this definition because we also get blues, purples, and whites. I think this is just a very condensed idea what they have here. And obviously it's usually near the south or north magnetic pole. The word Borealis means northern dawn. I think the Australian ones just means Australian dawn because there's no real southern term. Auroras are seen at a regular basis at your poles, and believe it or not, they say 80 to 300 kilometers above Earth's surface, but in reality it's up to 800. Auroras occur all day long, it's just we don't see them. They are happening above our atmosphere in what we call the thermosphere. It happens up there, it's just at night we get more excitation and it's dark, so obviously it's easier to see stuff in the dark. The same as when we're at the observatory, we can't see stars during the day, despite people thinking we can. So the mechanisms behind auroras. It all just looks like a glow in the sky, but it actually comes from the sun. You get high energy particles emitted from the sun, and by high energy particle I mean like an electron. This isn't something you can see. It's very, very minute. If anyone studied any physics or any electronics, you know what an electron is. And it's obviously negatively charged. Particles are directed by the poles due to Earth's magnetic field. We'll get into that a bit further now in a second. I'll show you the structure of the Earth's magnetic field, and then I'll make everyone mad when I tell you the truth about the magnetic field. The energized particles interact with gas atoms in our atmosphere. We'll talk about that a bit more. Well, thermosphere, as I said earlier, that's the upper layer of our atmosphere. And the strength and orientation of Earth's magnetic fields justifies the type of auroras you see at night. So there's usually 4 main kinds. Some people say 5 or 6. We're going to look at 4 different ones later on, but now we're going to go through the mechanism that starts it. Earth's magnetic field, the magnetosphere. This bright little ball down here is molten iron, and it spins. This is semi-molten, and this is solid molten here. Because these two spin, Earth turns into like a big dynamo, creates its own magnetic field. This is somewhat what the field looks like. You can picture a bar magnet going through Earth. Does anyone know anything funny about this magnet? This is south, this is Canada. This is north, and this is Australia. But if you use the compass, it would make sense, because your north has to point to south, and your south has to point to north. So in reality, your North Pole is the South Pole, and your South Pole is the North Pole. So relax. I know. What happened there?
It's a smart board. You're touching it, you're advancing.
I'm not smart with these boards. We got Mitsubishi projectors.
If you touch it, it goes to the next slide.
All right, keep my hands in here. The other thing with our magnetic pole, which gives Canada a really big advantage, is that the actual geomagnetic pole of Earth is actually located in Canada. It's not up at the actual North Pole. It's further towards us. That actually allows us to have enhanced auroras. So you see Earth's beautiful magnetic field, all uniform, looks really good. Now I'm going to show you the sun's. This thing's not good. It looks like a spaghetti ball. So where you've seen on Earth to be one North Pole and one South Pole, here you're seeing a variety of poles. So you're seeing North and South poles sticking out everywhere. That's where these lines are emanating from. So if you look here, you'll see some sunspots. This one here you don't see so much, but you'll notice in each of the images that these field lines are coming out of sunspots. That's really important, because the sunspots are a big factor in what happens with auroras. So, this is an image taken with our telescope last summer, and right here you can see 2 sunspots here and another 4 up here. There's actually people who get paid to count these. Don't know why. Seeing some of their graphs was pretty good. So, what they are is they're holes in the sun's outer layer, known as the chromosphere. And what happens there is you get 2 magnetic fields every now and then. You'll get one pointing up, one pointing down. When that happens, they cancel out. And when they cancel, particles from the sun's inner surface can actually eject through there and are released into outer space. These particles, like I said before, are like electrons. Can sometimes be protons, can be gamma rays. If anyone wants to know what gamma ray is, you get X-ray, you got shot with gamma rays. Or if you read the Incredible Hulk, that'll do it too. So we call them coronal mass ejections, or CMEs. One thing really big in astronomy is everyone likes acronyms. You'll probably get broke through on a few more. You can laugh if you want. They get really ridiculous. So CMEs happen on a regular basis, and when they do get carried towards Earth, we do get enhanced auroras. Because the sunspots follow an 11-year cycle, we can actually monitor the sunspots and know when we're going to have enhanced auroras for like certain years. Right now we're kind of in a low. The last peak was 2003?
No, 2011, 13.
Yeah, 2011. Yeah, I'm thinking 2 years back, or 2 cycles back. So right now we're in a bit of a lull. So now when we get through this all, I'll bring you up to a web page later and I'll show you how we can actually predict it. You can actually look ahead like 6 or 7 days and get an idea of what we're in for here. So CMEs and sunspots, just to give you an idea, this is a coronal mass ejection here. So you see the flare and we get the particles coming out. Unless they're directed at Earth, we don't get any effect. Otherwise, it just gives a great picture. The sun isn't actually dark here. They put a dot in front of it so you collect the image. Prior to developing telescopes like this, the only time we could view a CME was during a total solar eclipse, because it would block out the sun and you could see the outer layers. And here we see sunspots. I know it looks like a bad sunburn, but this gives you an idea of the size. That's the approximate size of Earth compared to those sunspots. So we do have a little bit of difference between us and them. So with the sunspots and CMEs, a CME, coronal mass ejection, is like a big gust of wind. We call it solar wind. Solar wind is always hitting Earth. When it does hit Earth, remember the pretty picture I showed you, the magnetic field? Well, it perturbs our magnetic field and like pushes it back like you would see a rock in a stream with water flowing around it. So here we see it folding back. Right here in these two regions, we call these the Van Allen belts. These are created by our magnetic field, and they actually protect Earth from all the dangerous particles that are released by the sun. If Earth didn't have a magnetic field, we probably wouldn't be here, probably be fried up because we get a lot of radiation. But because these Van Allen belts are at your mid-latitudes, they actually circle Earth like a donut. At your poles, you're not protected so well. So because of that, we get the chance for the particles to actually penetrate into the upper atmosphere and not be affected so much by the magnetic field and its protection that it provides Earth. So here's what happens. Changes in solar wind result in Earth's magnetic field fluctuate, known as geomagnetic activity, or some people call it geomagnetic storms. You can actually hold a compass in your hand. If you watched it for like 2 months, you'd notice that it moves on its own. This causes damaging effects to satellites, electronics. 1989, there was a big blackout in Quebec. That was due to that. What happens is we get way too much radiation from the sun, and it actually provides power to our own infrastructure. It powers infrastructure. It sets off relays at stations, and everyone here knows power stations. Whenever something goes wrong at a power station, you don't try to fix it, you just turn it off. Ask Japan. They didn't turn theirs off, it melted. So these high energy particles, when they come from the sun and do intercept our magnetic field, they actually spiral down magnetic field lines like this. We actually call it obeying the right hand rule, and we use B to identify magnetic field in physics. Don't ask. We just use it, try to make sense of it. So as you can notice, as they come in here, we're seeing them at the poles. This is where we get our penetration into the upper atmosphere. So what makes the colors? We got the particles coming into the upper atmosphere, and up there we mostly have oxygen and nitrogen. Believe it or not, nitrogen is a major constituent of Earth's atmosphere. Mostly what you breathe is oxygen or nitrogen. We all let it out, we don't actually process it. And when you do go to make pure nitrogen, you just pull it out of the air and filter it out and condense it. So the high energy particles spiral down the magnetic field lines. Then they hit either an oxygen atom or a nitrogen atom. If you hit an oxygen atom, you get reds and greens. If you hit a nitrogen atom, you get blues. They say blues, but I've also seen purples and some like really light blues that almost look like a white. So what happens there is the particle actually hits the atom, and one of the electrons on the outside of the atom gets really excited, and it goes out a little bit further. Well, just picture you got a kid drinking a Red Bull. He drinks a Red Bull and you try to send him to sleep. What'll happen? Nothing, he ain't going to sleep. So you let him out in the house and he runs around. So the atom gets hit with a Red Bull, and it got to let off the energy, so it lets off a little flash of light. And that's the mechanism behind making all this light. It's actually the same thing that works in these neon tube lights. All we do is we run electrical charge through, and we have pressurized gas inside. So most likely in this situation you would have nitrogen and oxygen there, because it is creating the two colors that we want. I could put up a fancy diagram of how photons and atoms work, but it would be just too much, and it's hard to explain without getting too technical, so we won't worry about it. So we know what excites the atoms. Now we want to look at auroral structures. So this is the one we get in Cornerbrook all the time. This is called diffuse auroras. This is just background radiation in the actual atmosphere just being illuminated. We're not getting anything real fancy. This is not a result of sunspots or anything. This is just background radiation. This is called the arc. Usually runs east to west. What you're actually looking at is called as a portion of what's called the auroral oval, which encompasses the whole pole of Earth. Well, both poles, but one on each. So this would be the arc. During periods of sunspots, we get the rays. And these rays are because we have the particles spiraling down the magnetic field lines. From that, we get curtains, and you also get the flickering as they move in the sky. And probably the best one, and whenever you ask anyone about it, I don't know if you've ever seen them here, this is called coronal aurora. Has anyone ever seen that here? It happens in Edmonton a lot. So what happens there is if you're near Earth's zenith. Zenith means you're near where the geomagnetic pole is to. And you look up, you're actually looking up where the zenith is. So if you could picture Earth's magnetic pole running through the center of that emission, that's what's going on there.
Steve.
You've seen it before?
I got a slide here, sorry later on.
Okay, well, I won't ruin it. So that's what's happening there. You're actually looking at the center of where Earth's magnetic field is coming out of the pole and causes that display of light. So, like I mentioned earlier, the coronal oval, or auroral oval, it's a ring of circumpolar excited atmospheric ions, or atoms. It exists in day and night, like I said earlier. But in this image here, you can only see on the night side. So this is the night side right here. We actually call this the terminator. And what happens due to magnetic, or the solar wind, it actually blows this back further onto the Earth on its night side. So it actually causes it to push down further into the latitudes, and we get our northern lights, as you can see right here. If we were there that day, you'd be able to see it. It was 2013, so we can forget about that. That's long gone. So this rotates and moves with Earth. And like I said earlier, although it's visible, you can't see, or although it's visible at night, it's visible at day, we just can't see it. So some interesting things that happen with the auroral oval. Long time ago, someone theorized this. It's called a theta emission. Anyone know what theta is? If you're doing math in school, it's usually recognized by an angle. So this is the theta symbol. It's a Greek letter. For the longest time, there was a few scientists who had theorized this happening. They never were able to prove it because they couldn't see it from Earth. Then they finally put up a satellite called SOHO. We're going to talk about that in a bit. Another terrible acronym. But SOHO got out far enough from Earth and took the image. And what happens is Earth's and the Sun's magnetic field align for a very short period at night, every now and then. When that happens, we get an aurora actually arc right across the circumpolar circle. And we get what's called a theta emission. I thought it was pretty cool. Especially if it was something that you don't use, well, you wouldn't see unless you're outside of Earth. So how do we study auroras? I just mentioned SOHO. That's this satellite right here. SOHO stands for Solar Heliophysics Observatory. That rotates around the sun just ahead of Earth. Because of that, we can give full forecasts of what the sun's doing. The other thing we do, well, we don't do it, NASA does it, is called sounding rockets. This is actually taken up in Alaska. They fire rockets up during auroras, and they take samples as they travel through the atmosphere. And from that data, they're able to try to determine the strength of the magnetic field and what is causing the activity that night. Usually when they do it, they send up like 3 rockets at a time. Now we're not talking like big rockets, only little small ones. Nothing like those SpaceX crazy guys sending up cars and stuff. It's only auroras. So forecasting solar weather. Remember I mentioned how SOHO orbits around the sun the same as we do? If you look at this diagram here, this is Earth. This one here is SOHO, and this is another solar observing satellite. 3 of these orbit the sun all the time. Because they're orbiting the sun, we can get a full solar forecast. So these little spirals you see coming out of the sun right now, they're actually caused by the sunspots I was talking about earlier. These are CMEs ejected, and these are high energy particle bands. When they come in contact with Earth, and you see this, if you follow up here on your date, you can actually try to predict when you're going to get your enhanced auroras. Believe it or not, I thought this was pretty neat. This pattern that is created by these sunspots is called the Parker spiral. Anyone remember Parker Brother games? Their emblem is a spiral. I thought it was pretty neat. I'll show you some more with that later on. I'll show you there's actually I got the website up there and I got it ready to bring up after. And here we got another image. I just brought in another image of Australia, or Aurora Australis. I thought this one was great. It's pretty neat because it has the presence of Canada in space. That's Canadarm2. That's equipped on the International Space Station. It catches and repairs satellites. Probably keeps everyone's phones working really well and does a lot more up there than anyone can give it credit to do. So other auroras. Everyone likes to think that Earth is the only place that had auroras, and up until we started sending satellites everywhere and getting really good telescopes, we were the only ones with auroras, because we're humans, we're pig-headed when we think. Mercury can't have auroras, or Venus, sorry. It's too close, too hot, and gets way too much effect from the sun. Venus lacks anything sensible for an atmosphere to use because its atmosphere is so deep. This place, when you work in astronomy, this is the most boring place on Earth because we live here. We'll look at some from Mars, but there's a big reason why we get them on Earth, and it's the same reason why we'll see them on these four. What it is Earth has atmosphere enough that we can charge up particles, and everybody knows these four guys, they're just big balls of atmosphere. That's all they are. Not even really sure what's down further. We just know there's kilometer upon kilometer of just gaseous material. So for Jupiter, Saturn, and Uranus, we'll see some. And then I don't have one for Neptune because Neptune is a really hard planet to look at, and in order to get a colored image, you pretty much got to send up a lot of satellites, and that costs a lot of taxpayers' dollars. So we don't like that one. So here we see Jupiter and Saturn. Jupiter and Saturn's auroras, we wouldn't be able to see them with our eyes. These are actually ultraviolet. So this is above what we would see. But if you're at a dance party or something and they flicked on a black light, maybe you'd be able to see it then. But these two images were taken with Hubble. Jupiter's auroras were actually discovered from Earth with the telescope, whereas Saturn was through Hubble and then later on with the Cassini satellite. Second set of auroras we're going to look at, Mars and Uranus. This Mars one really sucks. Mars doesn't have much of an atmosphere. And what happened here for this to actually have it had a global aurora at the time. There was actually a big CME that intersected Earth, or intercepted Mars. And because it has such a light atmosphere, it excited the whole atmosphere. If there was a few Martians there, I'm pretty sure Curiosity or someone got a picture. But they just had a pink sky. Not real pink, once again, this one's in UV. And when you look here to Uranus, this is in infrared. So this is really dull light. So this is infrared's light that's given out from heat. So like when you watch a Predator movie and you catch someone walking through the woods. So we got 2 spots of auroras there on Uranus. Auroras on Mars don't happen very often. The only reason why we actually caught that one was because we had a telescope or a satellite in orbit at the time when it happened, and it was just lucky enough to get it last year. So right now I'm just going to cite a few sources that I use because I don't like to say that I know all this because no one ever knows everything they're talking about. They learn it from someone else. This book here, Aurora, Observing and Recording Nature's Spectacular Light Show. That's the cover there. Great book. Astronomy text. And then this website here is NASA's website. And I'm also going to show you another website now where you can do auroral forecasting. So, another great acronym, NOAA. It's the National Oceanographic Atmospheric Administration. This is called the Space Weather Dashboard. Most people are cringing right now because it's like way too much information at once. And to be honest, most times when I pull it up, I just skip the first bit and go right to the bottom where there's lots of images. And it looks good. So, if you look here, we can watch CMEs. This will keep you up to date, I believe, up to the day. And over here we can watch sunspots. So that'll keep you up to date on what's going on the sun. So we can predict the weather that's going on there. And of course, it's not like a CME happens on the sun and bang, it's here. No, it takes a little time. Usually after a CME occurs, it's usually 6 to 7 days afterwards. And if we go down further, we see this screen here that we had up earlier. So you'll see the Parker spiral in work now. And it looks like the image there for the 19th actually had some particles intercepting Earth. So if you watch, it's actually going through, this is February dates. We're actually hitting a low spot now. But as you can see, we have another spiral, or another branch of the spiral coming in. So later on in the future, you'll see another period of excited auroras. And last but not least, everyone's favorite one to watch, because this one pretty much gives it to you the night of, is the auroral oval. So this one here will give you a full day, and same thing again, you can watch this to see what your aurora prediction is going to be like the night of. And like I said, this isn't guaranteed, even though we can see like CMEs coming in towards Earth from the sun, you're not guaranteed that we're going to get enhanced auroras from a CME with the sun. But You know, you can watch it, keep track of the activity. There's people who actually set up magnets in glass jars and watch them to see when Earth is going to fluctuate its magnetic field and enhance the auroras. Does anyone have any questions?
Can you bring up the website address for me?
I'll mark it on the board.
Okay.
Oh, no, not with this thing. Tipping me off. I'll read it. No, no problem. Did that wrong, of course. It's W. Noah. There's also a bunch of other real interesting stuff on this website. And space weather.
I think you missed the GOV.
Yeah, the dot gov.
GOV? Oh, I did.
It's,
I'm not good with the website addresses. I usually just click them and make them open up for someone else. I'll fix it up in a second. Does anyone have any other questions? No? I was gonna bring a camera in, but there's a guy here who takes pictures. I didn't want to do that. You'll also notice here how where geomagnetic north is like right here. Yeah, it's tricking me. So you can notice now where geomagnetic is, North Pole's north, how the oval actually centers more around Canada than the actual North Pole right here, as mentioned earlier. So if nobody has any questions left, have a break. And
Done?
yeah, that's it.
Okay.
Don't want to get too in depth with it.
Good evening and welcome everybody. I'd like to welcome you guys here as well. My name is Jordan Brown. I'm with the Labrador Heritage Society, head of Land Branch. This evening I will introduce our next speaker. She's a traditional Inuit knowledge holder. She's been all across the north. She's a published author and painter. She's a traditional Inuit storyteller, and she's currently working on her next great adventure, motherhood. I'd like to introduce Monika Rumbolt.
Hi everybody. You know, it's so funny because like I'm standing out by this door and my heart is just racing and I'm like, God, why don't I ever present like a PowerPoint of what I want to do? It might make things easier. But an Inuit elder told me, they said, when you do a story, when you tell a story, think of your ancestors. And quite frankly, I think 400 years ago in Labrador, they did not have PowerPoint. Who knows? But I'm pretty sure they didn't. So before I get into the story, I just want to give you like a little bit of a history behind our culture, the Labrador Inuit culture, and just a little bit about myself and how I kind of came into the role as a storyteller. And I say came into it because I don't think anybody really goes on a mission to be a storyteller. I was told it's always something that you have, and it's something that you walk into. So, just to start off, I'm just going to introduce you a bit to the culture. First, I'm sure a lot of you are like, oh, what is she wearing tonight? It looks pretty cool. Well, tonight I decided to dress in traditional regalia. This here is an amuti. So, if I put it up, you see the big hood? Yeah? It's pretty spacious, right? So it's funny that he mentioned motherhood because this is the type of thing that we would carry our children around. We were very nomadic. We always walked. We followed the caribou. We followed the seasons, right? So the summer we stuck to the coastline, and more towards winter we moved inland. So our children would go up in the back of our hoods. Now this kept them very warm and safe. And during those cold nights, while our husbands would be away, we would do a lot of throat singing. So has anybody ever heard Inuit throat singing? Yeah? Okay, so it's like it's like really deep in your chest. So another purpose the hood had is that we would put our children in it and we would throat sing with somebody else. And the swinging motion and the vibration from the throat singing would soothe the baby. So it served a lot of purposes. And much like the Inuit culture, everything that we do serves a purpose. So I grew up on the south coast of Labrador. I grew up in a very beautiful little town called Port Hope Simpson. I'm sure some of you may have traveled through the area, especially now that we have a road. Well, I grew up in, I can say, a very traditional household. My grandfather was a trapper and a fisherman, and my grandmother, she was into the sewing and the knitting. She was a good craftswoman. So I kind of grew up with that influence that culture was important, and it wasn't really displayed that it was something that had to be, you know, preserved and displayed. It was more like a livelihood. And the way that they passed on the culture to me was through storytelling. And I always like to say we're a spoken people. The Inuit never really wrote down what they did. And this is why we're finding it very hard today to kind of bring back a lot of our culture, because it's not written down. We speak it, we tell it through stories, we tell it through instructions. So right now we're at that point where we're trying to bring that back. And this time we're writing it down. So, of course, growing up in that type of environment and learning those ways from what I say my people, our people, the Labrador Inuit, I grew an appreciation for where culture stemmed from. And it stemmed from the heart. I could see it in how my grandfather sewed his nets together. I could see it in the meals that my grandmother prepared. I could see it in the land that I grew up on. And that type of inspiration kind of pushed me to be the person I am today. So I just kind of want to explain that first, because when we go into storytelling, storytelling was not only a way to pass the time, it wasn't only a way to preserve culture, but it was a way of making things make sense. Does that make sense? It was a way of giving explanation to the world, and it was a way of bringing us closer to the world. We are a very land-based people, right? We have spirits, we have connections to the animals, we have traditions, we have cultural practices, and they all tie in to where we fit in the world. The Inuit culture displays us as a person, but it never puts us above anything else. In our stories, we are seen as the ones who are kind of in the midst of the chaos. But the way that we are described, or the reason we're described as that, is because that's the way our functioning world is. Back then, again, 400 years ago, where there's no PowerPoint, it was chaos. It was chaotic. You were constantly looking for food. You were constantly looking for shelter. And you had phenomena like the Northern Lights that were absolutely terrifying. Think of yourself 400 years ago without Google, looking up at the sky and seeing that. It was a little terrifying. So we tell these stories, and we kind of help make sense of what things really are. And that's what really kind of developed our culture too. So tonight I have two stories for you about the Northern Lights. And forgive me if I speak a little fast. It's the Bayman in me. So, and feel free, like, you need to slow down. It's okay, I'll slow down. So, what is our tie with the Northern Lights? They are terrifying, absolutely terrifying. If you look in any culture, any Northern culture, so the Innu, the Inuit, the Cree, the Mi'kmaq have stories about them as well. they're seen as very terrifying beings. There's a few things they always tell you growing up. Never whistle at the northern lights. An old Inuit legend said if you whistle at them, you will make them very mad and they will come down and they'll give you a cut across the head. Yeah? But if they ever did that, another Inuit legend would say, clap at them. Apparently they're terrified of clapping. I don't recommend you go out and do either because somebody will have questions for you. So, I mean, if I seen you clapping at the sky in the middle of the night, I'm going to let you do your thing, but somebody else might have a question. So, and I mean, these are the things that we perceive as stories, or they originate from stories. There's also legends that they're omens of war. If you see strong northern lights, it means your enemies are preparing to fight against you, right? There's also legends that they're spirits in the sky playing soccer. Well, I say soccer, but they're kicking a ball around. They're spirits of deceased children. They're angry spirits. Or they're the creator. Now, this is a lot to take in because every different culture, every different community, every different person is going to tell you a different story. But that's the beauty of it. We have so many stories, they're all very entertaining. So I'm going to tell you two. And there's one story that I always like to tell children. And it's the story of the Northern Lights. But like every story about the Northern Lights, it's not about the creation of the lights, but it's how the lights affect us on Earth. Does everybody know what Labrador Light is? Yeah? I've got a couple ladies got some fancy jewelry. Looks good. So the story that I'm going to start off with is Tiatsuk, the shadow monster. Now this was a pretty bad dude. Now long, long before the fox and the rabbit chased each other across the sky as day and night, it was complete darkness. Pitch black. Not a star in the sky. The only light that can be seen was from the northern lights and fires in the center of villages. Now this was a very, very, very bad time on Earth. Storms raged, high winds, dark, twisted creatures. And the people were very scared. So in this village, this one particular village on the coast, there was a little boy and his two grandparents. And they lived in this warm sod hut. And outside the hut, there was this big roaring fire. And the grandmother had always said to the child, she said, never leave the light of the fire, for if you do, something will come and get you. So the child sat close to his grandmother, and he listened to her stories, and he ate char, and he watched out through the window. And this one particular night, it was dead silence. Not a sound was made in the village. His grandparents, weary of what was going on, had taken their kakavix, which is a spear used for fishing. It's got a little tip on the side. And they went outside. And there was nothing but silence. So the little boy stood up and he looked outside the side door and he listened. And he could hear their footsteps going further and further away. And all of a sudden, bam! Just like that, he heard a terrifying scream from the woods. Run! 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 It's Tiatsuk! Tiatsuk emerged from the woods, breaking one of the kakavix in half. The little boy, seeing the monster, this decrepit, black shadow with long fingers and hollow eyes, got scared and he ran, terrified, towards the cliffs of the shore. And this monster climbed over the rocks after him. The little boy, feeling scared, out of breath, kept running, for he knew if the monster got a hold of him, that would be the end. So as the little boy got closer to the shore, he fell on a rock and he said, I can't run no more. I'm tired and I'm scared. And he looked up at the northern lights and he pleaded with them and he said, please, spirits, give me something to keep me safe. And the spirits, not normally concerned with us on earth, heard the little boy's cry and they felt sad. They felt a grief for the little boy. So, looking down upon him, the spirits flared up and created this swirl across the sky. And with one sharp bang, they jolted down into the cliffs and left a glowing rock. The little boy got up and ran with all his might, knowing that the monster was right on his tail. Picked up the rock, noticing that it had the same shimmer as the northern lights. He picked it up and he showed it towards the monster and he said, leave me alone. The monster snarled and moved its dark fingers, coming closer and closer. So with the little courage that he had and this glowing rock, he moved forward and said, no! The monster's guts crawled, hissed and moved back. The boy sensed a little more courage in him. He kept running. No! Go away! The monster snarled. And just as the monster was about to turn away, the little boy touched him with the rock. And the light came out and slipped over the shadow, grasping it by the hand and pulling it down to the earth. The monster screamed and hissed and spat. It could do nothing. The light absorbed it, dragging it further and further down until it was gone. And here the little boy stood on the cliff, holding in his hands what we see today as Labrador Right. So there's a story about that, right? That's why we value Labrador Right. Labrador Right is seen as a gift from the Northern Lights. But there's something else in that story too that maybe some of you caught on to. There's a lesson. How the grandmother would tell the child, never move away from the light, never move away from my sight. Like in many stories, it's to teach a lesson or it's to prove a point. And in that lesson, it shows that yes, the Northern Lights do have a merciful side. Yes, this is the explanation to where we get Labrador Right, but never stray far away from home. To a young child, I mean, it makes sense, right? So there are little things like that. So it's a very popular story told in Hopedale. Hopedale is up north, as many of you know, and they have huge cliffs of Labrador Right. So they kind of have a thing where they say that's where it originated from. That's where the aurora came down and clashed into the cliff. It's a very beautiful place. I recommend everyone go to it. And you can get Labrador Right for free. You're just kind of picking it off the cliff. So there's another story I'd like to tell you too. And again, it's a story of purpose. This one here I found more in a southern region. And I find it's a really good fit, especially to the South Coast. Now, some of you may know, and people who are from the South Coast who have a spouse, things like that. The salmon fishery is huge down there, right? So the salmon fishery provides food for us in the summertime. It's a cultural practice taken up by many homes, and it's something that's very well managed, right? We do it for conservation, we do it for cultural reasons, and we also do it as a community event. So we harvest our salmon. We also harvest salmon for elders and people who are unable to go get them. So it's pretty interactive between the members of the community. Now, this story was told to me. It's not only popular here in Labrador, but it was also very popular in Alaska and the northern part of Greenland. And it's a story about how the Northern Lights affect the cycles of animals, or how the Northern Lights affect the way that we perceive things, or the way that we try to explain things to ourselves. So our story starts off at the beginning of creation. So again, the world is completely dark. And we have the salmon. And the salmon are just kind of swimming around in the ocean. They're really lost. They don't know what to do with themselves. They're trying to find home. But they can't. Because they have a feeling that they're supposed to be somewhere, but they don't know where they're going to be. So the Northern Lights are flickering up above, and they see the salmon in this turmoil, and they feel bad for them. So what they do is they send a very, very wise creature to them. Now this wise creature walked across the ice pan with its big paws and stood on the edge of the ice and called down to them, "Come to me, and I will tell you where to go." So the salmon came up, and they all looked at him, terrified. And the polar bear said, "Follow the lights, conquer the mountain, and you will be home." And one little salmon spoke up and they said, "We're not strong enough. We are not meant to swim upstream. We'll die." And the polar bear said, "Follow the lights and conquer the mountain, and you will be home." And the salmon, they spurred and they fought and they argued and they said, "We can't do it, we can't do it. It's impossible. It doesn't make sense to leave the salt water and move into fresh. It doesn't make sense. We're not going to make it. We're not strong enough." So the polar bear left them, and as they fought among themselves, the decision became clearer and clearer. If we are to find our home, if we are to find our purpose, our sense in living, we have to go with what he said. So the salmon gathered together, and they found the stream. And one little salmon looked up, and he said, "If this is what we have to do, let us know." And as soon as the words were out of its mouth, the Northern Lights gave a soft, flickering glow. And they moved, just like the stream did. And the salmon said, "Then we will go." So they started in the mouth of the river, and they fought, and they fought, and they fought. They went over rocks, they went upstream, they went up waterfalls, they went in rapids. And more, the challenge became clear. They were not going to make it up the mountain. But the further they got, the brighter the lights shone. And they flickered, and they encouraged the salmon to keep going. So the salmon went until they got to the base of the mountain. And they looked up, being tired, being worn. Their numbers dropped. And they said, "We can't do it." The Northern Lights, again feeling sad for them, lowered themselves by the stream. The salmon, seeing this, jumped and caught themselves in the glare, and they found themselves moving within the rivers of the Aurora Borealis. The Northern Lights lifted them as they climbed up the mountain and landed into the small stream above, where they found their home. They found their purpose. But as being part of their job, the lights had said, "You cannot stay here, for I have helped you. It is not an accomplishment of your own." The salmon, sad by the sight, begged and pleaded and said, "Please, we're finally home, we're finally here." The light said, "No, you have to leave." So, the salmon, being torn apart, had made a deal. "Well, can we come back?" And the light said, "Yes, only once a year." but every time you come back, there will be fewer of you. The salmon agreed to their fate, and they went back to the ocean. That is the story of the salmon migration. It's a story that tells us that there are cycles. Many of you know, especially from a conservation perspective, that fluctuations will always happen in animal patterns. Sometimes there's lots of ptarmigan, sometimes there's not. Well, for us, it also explained the changes for our salmon, the changes for our hunting patterns. It also gave us a reason to believe why they did it, why they continue to do it. And this is what drives us today. This is what provides a cultural background into what we do. And it's a great way of trying to explain it to children. It's a great way of passing on knowledge, but it's also a great way of preserving what we are. And that's why we still do it. Thanks.
Hey, that was awesome. Thank you, Monika. Beautiful stories. Our final presenter for this evening is going to be Larry Jenkins. Good timing, Lisa. The unique landscape of Labrador West attracted Larry when he first came here 45 years ago, and it still does today. Larry's photographs of the area have appeared in numerous magazines, tourism and advertising brochures, postcards, and calendars. In 2002, he published a book of photographs of the area to commemorate Labrador West's Come Home Year. For his efforts in promoting Labrador to Canada and the rest of the world through his photographs, Larry recently received a Labradorian of Distinction Award. Larry is a landscape nature photographer, but he is best known for his images of the Northern Lights, aka the greatest natural light show on Earth. Of course, we all know Larry, and I'd like to welcome him up to show us some of his work. Much off, or?
No, that's fine, as long as I can see Peter over here, that's good. My first encounter with a smart board, let's screw something up here. I'd like to apologize first of all for my voice, and I hope it can hold out for the next little while. I have an encounter with a bit of a flu bug, and for a couple of days I almost totally lost my voice. Can you hear me okay?
Yeah, you want the microphone on?
What?
You want the mic system turned on? Make it easier for you?
No, I think this will be okay, I think. When Karen asked me a while back if I was interested in doing this, of course I said yes, I'd be really interested in showcasing a few of my photographs and talk a little bit about how to photograph the Northern Lights and so on. And so I asked her what she really wanted me to do. She said, well, basically I just want you to get up there and show some of your pictures. So I'm going to spend a few minutes talking about how to photograph the Northern Lights, basically what you need. I won't go into any great amount of detail about technical aspects of your camera, you know, whether you shoot in RAW format or JPEG or whatever. But I just want to go through some basic things that you would need to get out there at night and photograph the amazing Northern Lights. So I've listed a few things here on the first slide. Basically, you have to get outside of town. Leave town, because you're not going to be able to get very good shots if you're distracted by light pollution, street lamps, and people's porch lights, and so on and so forth. The time of the year, photographing the Northern Lights, I find that September to April are the best times. Northern Lights tend to favor the autumn and spring equinox. If I look back over the thousands of pictures I've taken over the years, most of them would be from October, November into March, April. That seems to be the best time of year. But I have actually taken photographs for the whole 12 months of the year. Just a couple of years ago, I was lucky enough to get a shot of the Northern Lights in the month of July, which is kind of rare. The time of night, usually around midnight, but I've gone out right after dark and actually photographed the lights, so it's not necessarily long after the sun goes down. Camera gear, I suppose with smartphones the way they are today, you might be able to take a shot of the northern lights with your phone if you had some way of holding your camera steady. Your camera, make sure your camera is set on manual focus. Most cameras now are autofocus, and it doesn't work for the northern lights. Your camera will be struggling to find a point of light to focus on, and basically turn off your manual focus. I made a habit lately of taping my camera to the infinity spot on my lens, because I run into a few problems with the dial actually shifting off of the infinity point on the lens, and I've come back with pictures that are blurred. You need a wired, at least a remote shutter release of some sort, wired or wireless. You can't actually be touching your camera shutter button with your finger when you're taking a picture of northern lights. You'll create a blur. Lens, basically wide angle lens of any sort works best, because the northern lights are there and the entire sky is filled with the lights, and you want to gather as much information as possible. So a wide angle lens somewhere in the 15, 25 millimeter range. But if you're using the kit lens that's on your camera, it's got a 24 to 80 range, that's fine as well. And tripod. I should put that right at the top of the list, because that's one of the most important things you want to have, is a good sturdy tripod to mount your camera. How am I doing so far? Great. You can still hear me back? Great. Other things to consider, make sure you have spare batteries with you, at least a couple of batteries charged up, a flashlight, a headlamp, preferably something you can stick on your head, because you're out there and you're fiddling with controls in your camera, and you need some kind of a light source. Preferably not a really bright light, because I find some of those LED lights are really, really super bright, and when you turn it off, then you're blinded for a minute, and it takes a while for your eyes to focus to see in the dark. Warm clothes. Northern lights are mostly a winter thing here in Labrador, at least from November till April. So most nights you go out, it's going to be cold. So dress accordingly, and those the toe warmers are great. I go through cartons of those. Check out some of the space weather networks. A couple I check. I gotta get one that Steve had written down here earlier. I wasn't aware of that one. I check like spaceweather.com or Soft Serve News or whatever. It gives you a bit of a heads up as to what might be coming your way. And maybe you want to take a lunch. If you plan to do an all-nighter, take a lunch, a bit of music. I've done that. Okay. There we go. Find the button. Lots of things can go wrong when you're out there in the dark with your camera. All of these things, plus lots of others, have happened to me. Never leave a filter on your camera. I'm sure you wouldn't do it intentionally, but I've done it. I've gone out there, and there's a polarizing filter left on my camera. And I'm looking through the lens, and it's quite dark, and I said, what's going on? And so I adjust the exposure, and it still doesn't look great, and I come to realize that I had a filter left on the camera. And of course, don't forget to turn off your autofocus, as I mentioned earlier. I've actually lost my remote control by getting out of my car, opening the camera bag, and my shutter release cable fell out. I couldn't find it. So I went through a few shots with just using my finger on the shutter release on my camera. Managed to get a few shots, but they weren't great. As I was back in my truck, out of where I was parked off the highway, there was my remote control shutter release cable just lying there in the snowbank. Your lens will fog up during extremely cold weather. That's a given. If you're out there long enough and it's 30 below, 40 below, your fingers are freezing, your toes are freezing, but your lens will also freeze up, it'll frost over. That can be a problem. Fog moving in over open water, I've encountered that. Sometimes it's real loose and sometimes it can add a little dimension to your picture. Oh, well, I'll show you a couple of examples later on. Stray light from snowmobiles and cars. It's hard to get far enough out of town that you won't encounter a vehicle, a car, truck, or a skidoo light, skidoo with a headlight that's going to obstruct your view. No matter how far out of town you are, away from any kind of artificial light, ambient light, you're going to encounter stuff up there in the sky that's going to interfere with your shots, like satellites and planes and so on moving through the scene. Okay, now I didn't just want to load up a whole bunch of pictures and go through a gallery of my stuff, so I decided to do up a few categories of my Northern Lights. These are from the days of film. I only got into the digital realm of photography about 8 or 9 years ago, so I shot film exclusively, slide film, and I would send it off to a lab in Ontario somewhere and have it developed and wait for the results to come back. And in the early days, the results were pathetic. I had no idea. It's been a bit of a learning curve, and with slide film, of course, you couldn't always crank up your ISO to 800, 1600, 2000, whatever, and you know, you came back with 36 slides, your little blobs of green in a dark sky, and that was the extent of it. This is one of my earliest shots here. I put a couple of those in because this required a bit of a long time exposure with slide film, with a 6400 ASA or whatever. So it's probably a 60 to 90 second exposure, and you notice what's happening to the stars. They're not little pinpoint dots anymore, they're kind of a little bit starting to develop into star trails, and that can be a little bit distracting. This particular shot, again, is from the days of film. The stars are nice and sharp there because that was a shorter exposure, because this blob of light was just sitting there. That was back in about 1990, 91, shortly after the Solar Max that Steve was talking about earlier, that knocked out power all over Quebec, and people saw Northern Lights as far south as Mexico. And on that particular night, that was probably a shorter exposure. And I just want to point out the little star constellation. There's that Venus, Steve?
Yeah.
Yeah. And that shows up in a lot of my Northern Lights shots because it's always there in that part of the sky, that time of year, November, December, whatever. Okay. This was a shot I took again from my earlier days. Up on Menahek Lake back in, I think it's 2001, 2003. The sun had just gone down, the sky is still orange. And I went out on the lake right down in front of the memorial, if any of you are familiar with that part of Esker and the Menahek Lake area. And another one of my very earlier shots taken in 1995. I always like to have a little bit of foreground detail in my pictures, so you know, if I'm at the cabin, I just light up a few candles to illuminate the windows and move on up the lake and take a few pictures. And this particular shot here, which was on the cover of a book that I had published back in 2002 for our Come Home year. And I got a call from a friend of mine, Jerry Rideout. He said, "Larry, no, the lights are out." I said, "Jerry, it's not even dark." He said, "Yeah, it's dark up here on Smoky Mountain." And I had asked Jerry to give me a call anytime the lights might be out, so he did. And I scrambled, got outside of town, went out onto the road to Dooley Lake, parked in the middle of the road, and started shooting away. And the orange glow is accidentally started up my car with the remote start in my pocket. It's the very first vehicle I had with the remote start. And in that particular vehicle, the day running lights were the amber park lights, so it lit up the yellow line for a little bit there. It's kind of added a little bit of dimension to the picture. And the next category I want to talk about, Northern Lights basically take on different shapes, some basic shapes. Steve mentioned a couple earlier. Some of these names I just made up because it looked to me like a ray or it looked like a pillar. A vertical shot you don't often get the northern lights going up in pillars and spires and rays like that, but anytime they do, you need to touch your camera up and get like a portrait or a vertical shot of it. This was taken on just outside of town, what I call the man-made lake. It's the old Dolomite Quarry off of Javin Road. And it's a place I go to often to take pictures of the northern lights. It's a beautiful spot. I hang out there, and it's a nice spot to go visit because it's a bit of a sanctuary for migratory birds, geese and ducks, stuff like that in the fall of the year. This is a corona that, I think it's a corona, Steve. I call it a corona. It's just sitting up there right overhead. It doesn't very often come down close enough to the tree line so that you can get a little bit of, foreground detail. I always like to have trees or buildings or snow or moonlit ground as a foreground element. But I do every now and then take a picture of this. It's a crown that just sits overhead. It sometimes hangs there for hours at a time. Another basic shape is a curtain. This was taken in June 23rd, actually, 2015. I pulled an all-nighter on top of Smoky Mountain. I went out around 11 o'clock when it was just getting dark. Never really gets totally dark here in Labrador at that time of year. And I'll include a few slides later on, but that's one of the ones that I took that night. That's the idea. That's an example, I think, of a curtain. It's like this is like a curtain, like that's just blowing in the wind. Oval. The oval is a common shape of. No, that might not be exactly an oval. There might be another name, but I call it an oval. And that's one of my newer shots I took back in November 7th on Albert Lake, which is a place I go to often. I got a cabin there, but this is not near my cabin at all. My cabin is further down in the lake. But it was almost a full. Yeah, it was basically a full moon, just coming up over Wabash, actually off to my right. And I like taking pictures on moonlight nights, believe it or not, even though sometimes the moon can overpower the northern lights. The northern lights not really basically that bright at all. But the moon lights up the foreground, right? It gives you some nice detail. You can see the moon shadows there, and so on. Yeah. And I'm sure that's not a name of the Northern Lights tornado, but this one did remind me of a tornado. Again, on one of my favorite haunts down at the old Dolomite Quarry. And I think, Steve, it's probably a planet there, maybe Venus, the evening star.
Oh, I don't know when you take the picture. When you took it, I can tell you. You told me. I'll check the reaction. I'm trying to figure it out. It's two pictures.
So, I call this one a tornado shape. There's the arc, of course. Again, that's the same picture I showed you earlier. The arc just sits quietly. Northern Lights can be very quiet and boring. You can take 25 shots and look at them later on your computer, and they're basically all the same. Sometimes they're wild and jumping around. You get a shot, and then they're gone, but you look off to your left, your right, or behind you even, and they're there, and they're kind of hard to capture like that, but nice like that with the. And there's the band, the basic band. That probably sat there for a couple hours. This is at our cabin, my boat hauling on the beach, and I'm not sure if I took it through the window, but I had taken pictures through the window. On a cold night, my camera, I had it set outside, and I'm sitting in the chair inside having a beer, firing off shots with a wireless remote. But I call that one Midnight Rainbow because it was around midnight. That's the band. And then I call that a funnel. Again, Aurora people might have a different name for it, but it's like a funnel coming out of the guy's funnel because that's a cabin on a road going to Dapper Lake. I remember going in there, and again, that's from my days of film, which I got scanned and I got digitized after. But that was just after dark. So forget about the midnight time, and that's the only time to go out. And how do you know it's right after dark? You see the reflection of the western sky, which is behind me, in the window. So the sun had basically just gone down, showed a little earlier. And I got stuck in the snow on that road going here. That's why I remember it so well. And then there's I call it a potpourri, a mixture of northern lights. You got some curtains, or you got some colors, and you got the oval, and you got a little bit of color in there too. This group of slides I would call distraction, stuff that can get in your way when you're out there all by yourself and not expecting anybody to come by on a skidoo, but this happened and I saw it coming and I didn't mind because we're at the cabin. I had lit a couple of candles inside and my wife Trixie in there sitting down reading by candlelight and I was out shooting away on the lake and I saw a skidoo coming down. The lights weren't great, but I said, well, I couldn't resist the shot anyway. And I had taken a few shots and I saw a skidoo coming down the lake toward me and he started to, the headlights in the foreground kind of ruined the shot. So I said, I'll wait till he passes, but just before he got, maybe 20 feet away from me coming to my left, I opened the shutter and let him ride through the scene and this is what happened. You get the continuous light from his tail light and his headlight there. That can ruin a shot for you. The lights on the left, the three street lamps going up towards Smoky Mountain. This is on Beverly Lake. I was over on the other side by where the community gardens are. But the distracting light on top of Smoky Mountain, it wasn't there in the first few shots because I was there for a little while. But then all of a sudden this light showed up. I realized it was somebody in a car up on top of Smoky, up by the old communication square up there. I drive up there often. You can't anymore because I think IOC's expansion 3 is kind of taken over. But anyway, that's kind of a little bit distracting. Clouds can get in the way of your shots as well, but sometimes they can enhance your pictures. This one, I call it Green Lights, October Nights, and it was taken from over on Sandy Point looking toward Labrador City. And shortly after, it did cloud over completely, but I did get a few shots. And the clouds kind of gives it a little more drama, right? You think? So, and that one there with the clouds, of course, I was on Albert Lake one night. And it clouded over basically before I got there. I said, well, I'll take my camera and take the shots anyway, the clouds, because they were really dramatic. And then eventually it got totally dark. And it might have even rained. It was in October. And talk about things that can distract and get in the way of the picture. See those little lights here, one there, one there? These are solar lights on people's cabins just across the lake. It's hard to go to a lake anywhere to take a picture. Even if people don't have their cabins, you get lights from their solar lamps on their deck and so on. And again, I just stuck that in there because clouds kind of add to the overall scene. They're kind of pink because I'm picking up some light pollution from IOC and that city, which is only like a few miles away from where our cabin is. And the Big Dipper, just sitting there. And fog can be a nuisance too. I did get a few shots on the lake that particular night, and I said, oh shit, the fog is moving in, but I did get a few shots before it totally obscured the scene and fogged up my camera, so I hit it back into the cabin. And again, this is a shot taken on top of Blueberry Hill, looking out over Flower Lake with the lights of Wabash on the left, Industrial Park and that city and Odyssey off to the right. And that big white bank of fog down there is just the fog bank on the lake. And I saw it before I drove up there. And I was shooting away. It was a fairly good shoot. I got quite a number of shots. And but then the fog kind of moved up the hill and the lens got fogged up and I was getting wet. My camera was getting wet. So other things that, this is not another nice shot, but I was down on Albert Lake one night waiting for something to happen and just took a picture of my friend's boat there. And the moon and the little Thetis off to the left there, but a satellite moving through the scene. I didn't see it. You don't have to see that with naked eye, you don't, but the camera will pick it up. And this was from my November shoot back, 7 November, same night I was on Albert Lake. I started out on Sandy Point. I drove down to the beach there, and the lake is just cut over, and I took a shot looking across toward IOC, and the lights weren't bad. I just wanted to get a couple of shots and get out of there. But you see that long yellow line there? That's actually somebody who's out on Sandy Point, the extreme end of Sandy Point there, who went along with the beautiful northern lights, great, wow, and left their car headlights on. I wanted to yell out and say, well, it would look a lot better if you just turned your headlights off, right? And Now, city lights can add to your picture, like a nice skyline of Lab City. I take a lot from across Little Wabash Lake over by the plane dock there. And this particular one was taken in Sandy Point a couple of years ago, looking down toward the bridge and sea. And I like the perfect reflection in the water, almost like a horizontal Valentine is sitting there. And another night up on top of Blueberry Hill, it was partial moon at night. The northern lights were all around, so it was almost like a daylight. You could almost read a newspaper by the light from the northern lights. It was early night, actually, and I call it twilight curtains because I make people believe that that's actually the sun over there, like evening sky, but really it's not. It's light pollution from Wabash. So, but it's you can get away with saying it's a twilight shot. You want to include some foreground detail in your picture. You always run into problems with wind, right? If, you know, the wind will move the trees and register as a blur. In this particular case, the flag on his cabin is kind of moving and it creates a bit of a blur. I put that one in, that was a July shot, the only shot I've ever taken in July. And again, it was kind of windy night, you can see the lake's kind of a little bit windy. But the trees in front of the plane are kind of moving, and it creates a bit of a blur. Okay, auroras by moonlight. Now, moonlight is not always your friend when you're taking pictures of the northern lights. The moon is bright, overpowering. But if the lights are strong enough, it really helps. I find that only the weakest northern light shots are adversely affected by moonlight. So that's one of my latest shots down on Albert Lake, November 7th. I call it November Sky. And again, there's the moonlight shot on Albert Lake, full moon, but you know, I mean, it lit up so nicely there. And that one of my very earlier shots, call it Far in the Sky. It was during the second last Solar Max, 2001, so it was right after the big 1989 shutdown Hydro-Quebec, and because lights were so powerful. And again, Moonlight Serenade on the top of Blueberry Hill. This one here was taken out at on Wash River in May of 2015. I had that one published in the Sky News magazine. It was a moonlight shot, just like third quarter, last quarter moon, whatever, off to the left, and just lit up the rocks and down where the old bridge used to cross over Dooley, Wash River, as people will know. And again, on one of my favorite spots down at the old Dolomite Quarry camper across the way there. And reflections. For years, I didn't get a shot of northern lights over water. I don't know why. I guess it was just a winter thing for me then. But the last few years, I've been able to get to a lake somewhere and get some northern light shots over water. This particular shot, the lights don't reflect. You don't have a duality of the lights in the water because there's a slight breeze on the lake, but it gives her a nice soft foreground. And this is the perfect reflection of the lights. This is again from Sandy Point. And a moonlight night. I find that on moonlight nights the sky takes on a bit of a daylight look, blue as opposed to just dark or gray. And again, Albert Lake, where else? And this one here, man-made lake, where else? Sometimes the northern lights, to me at least, take on shapes of different animals, creatures, whatever. I get a couple. In fact, one just a little ways back, somebody said, Larry, you should have called that Big Bird because it did look like a big bird. Anytime I saw a print of that, I call it the mare's tail because you can probably see like a mare right here and there's a tail, but that could pass as a tail as well. Again, that particular one there, reflection, so that one, I don't know why that same copy in there. Heavenly bodies that sometimes encounter the little star constellation, the Seven Sisters, there, Pluto's sitting right there. That shows up a lot. You don't see it. Well, I don't see it till I get back home and have a look at it later on. And the Big Dipper is always a prominent part of my northern light shot, especially looking toward that part of the sky over the northwest. That time of year. I don't always see it there. I'm not looking closely enough, but I'm kind of blurred by the lights or whatever. And I'll come back and I got half the Big Dipper. I said, why didn't I pan the other way and get the whole Big Dipper in it, you know? But at least in a lot of them I do have. And a couple of planets, I think that's Venus and Mercury, and I have a title, and like the Venus and Mercury cavort that was taken down off the old Javelin Road a long time ago. Including foreground elements in the pictures I mentioned earlier, foreground detail. Running out of time? No? Okay. In this particular case, you got a lake, you got a little wharf sticking out there. This is right across Little Wabash Lake, right over by Lily's Plain Dock. I go there often. The one include the lights of Lab City with my Northern Lights shots, and that one again, another shot from November 7th on Albert Lake with the snow in the foreground. And Sandy Point, you include a little bit of water and they got a lagoon in the front there and the rocks and so on. Helps to balance out the whole composition. The clouds were not pink. Where do you think the pink comes from? In IOC, just across the way in Lab City with all those amber lights. You don't necessarily see that color. The camera picks it up on a time exposure. And now, this was taken on top of Smoky Mountain June 23rd, 2015, when I pulled an all-nighter. I went out daylight and came home daylight, which was about 4 o'clock in the morning. It never gets really totally dark here that time of year. The foreground detail there, of course, you got the moon. It's like a third quarter moon just going down, and about an hour or so after the shot, it did disappear completely behind the hills there, looking over toward Fairmont. And the white rock in the foreground, it's not snow. A lot of people think it's snow, but it's not. It's a white rock formation on top of Smoky. And that's right near where that big old radar thing is. I drove my truck right up next to it. Again, that one there. Another one of my early shots from way back in 1995, the cabin on Albert Lake, slide film, digitized and whatever. I include the cabin there and the moon, which was up about here when I started and looking directly at me. It wasn't kind of washed out everything. But the moon is just sitting there behind the tree line, as you can see. And there we have a cruise ship up on Canyon Lake to include in the foreground. That's actually the hospital, taken from across by the scout logs, looking straight across. I was shooting away, the lights were further down the lake, and I came around there and said, well, why not, just lump it in there, see what happens. I just go through a quick gallery of a few of my pictures that, and then flew up with another little category after. Again, one of my shots from there on Albert Lake in the summertime, or in fall here actually, in a different part of Albert Lake, and looking straight down the lake where we come off on the lake there. Gary Shaw would know, that's close to where Sub's cabin is. In 2003, we went on a skidoo trip up to Shaw Lake and spent a night or two in this little cabin here right off of the Tamarack River, close to Manahack Lake. And Northern Lights were out the whole time we were up there. I had my camera and I did nail in a few shots. But this is a little old cabin that's sitting on the back of a pickup truck, and with a gasoline lantern lit inside. A shot from across Little Wabash Lake, looking down toward IOC. You can see the smoke from IOC here, and lights from the park, industrial park, and the city, and that area. And again, this was actually St. Paddy's Day on top of Liberty Hill. That particular night, the lights were crazy, and there was a fair bit of color. Not as obvious as that. A time exposure will bring out the red more so. You see green, I think, better than you see red. But the camera will pick up any amount of colors there. And another night at the old Dolomite Quarry, just on a summer shot, with a full moon that lights up. Actually, it's in the fall here with the colors there. And looking across Albert Lake toward a guy's cabin with solar lights, and then up there. This was a May month. Up until that point, I had not gotten a shot in the month of May. Never mind. June and July, I had gotten shots in late August. This was on the 15th, actually May month in 2015, out on West River, right down where the old bridge used to cross over years ago. And I got tutor actually, I tutored a couple because this guy here was getting a bit anxious. He had his hammock all strung out, waiting for summer. I think it was actually left over from the year before. And if you get really, really bored, you can include yourself in the shot. I couldn't do that when I had a wired release cable that was this long. I had to stand to the side. I didn't want to put on like a timer or something. So a few years ago, I bought myself a little wireless remote. It's good for up to 60 or 80 feet. So every now and then I'll walk out in front and just do a selfie. But the thing is, it's about a 15 to 20 second exposure because the lights were getting a bit dull by that time. So I had to stand there and freeze for that long and count up the seconds with a remote control in my pocket. What I like about the wireless remote is that if you're out there in really, really cold nights, you can stick that little thing about that long in your mitt and keeps your hand warm in there with that little Tootsie finger warmers or whatever. It really works for me. Because I come back with frozen fingers like you wouldn't believe. I have a tripod that's got 2 legs wrapped in foam, but the other one isn't. And guess which one I always grab with my naked hand? It's the one that's not wrapped in foam. And I did really burn my fingers really bad one night, and actually I think I lost a fingernail on one finger. I know it turned black anyway. Doing pretty good actually. People don't know, this is over on Sandy Point, right at the extreme end of the point there. This is the light up on Wabash Mountain. It's a beacon of some sort, right, for aircraft and IOC. And that was in November last year. Okay. Now, I'm going to end off with this little group of slides I call From Dusk to Dawn, because it was the 23rd of June 2015, and I'd gotten a heads up from some space network group that there's a good chance that Northern Lights would be out in our area, like for that particular night. So I headed out. I had the gear all ready, and I was on top of Smoky Mountain up by that old radar square thing up there. Before it got totally dark, so I just hung around there, took a few pictures because it's beautiful up there, and rugged, and it was there's a lot of evening twilight shots looking over the town and so on. But by about 12 o'clock, I noticed the lights were starting to shape up, and I said, "Oh, darn, the clouds are moving in." But it didn't. A couple of clouds moved in and then kind of moved off again. But I think it was probably the very first shot I took, and I went from there. I came back off the hill the next day when I loaded pictures onto my computer. I had 220 shots. A lot of them were kind of the same because the lights weren't really wild. They weren't jumping around all over the place. They were kind of steady. They did move off to my left and for a while, or to my right, and for a little while they were actually sitting out over Lab City, and I got a couple of shots of that. But it went from that to that, and that's similar to what I showed you earlier with the moon. And I talk about distracting things. There's a lot of activity going on up there with the mine site opening up, whatever. That was almost 3 years ago. But there's a car coming up the road up the trail there, and just before it came over the crest of the hill, I managed to fire off a shot. So I got a little bit of a glow just before his headlights just blinded me. And from that, different configurations, different shapes and swirlies. And that's the old radar screen I'm talking about. And of course you see the smoke billowing out from IOC there, steam I guess we call it, and some lights from IOC and or the airport. And okay, now I got really bored. I thought I'd take a picture of my old pickup truck. So I was just sitting there really close to where I was actually, I shouldn't have even gone up that far because I had trouble turning around to get back down out of it, and it's 3 o'clock in the morning. Anyway, after that, a few shots after that, I decided to head back down the hill, because the lights were fading away by then. It was around 3 o'clock, 3:30. And it took me a while to get down, because that road was rough. It's still a bit rough, but it's a lot better now than it used to be. And as I was coming down, I actually driving right to the college here, I looked off to my left, and I said, geez, oh, the light's still out. And so I pulled off, went down by Beverly, by the community gardens there, and fired off a few more shots. This one here I called a Beverly Lake moment, because I guess some of the shots are, after having given up on them, you know, because they were kind of fading away, and I was tired of it, and I was hoping it would cloud over, so I'd go home and go to bed. And anyway, I ended up over on Sandy Point. So I went from dusk to dawn. The orange sky over here was from when the sun was going down. Of course, it doesn't go down very far, and this comes up again. And this is the dawn sky looking right down across Big Walrus Lake. So I'll end with that slide. So, thank you.